In this video, we'll take up differentiation of parametric function and rules for the differentiation of parametric functions. Parametric functions will be given in this form, that is, generally what we are given is we are given a function y is equal to fx, that is like y is directly related to some x square plus x plus 1 like that. But in case of parametric function, y will be depending on some third variable, that is, let's say theta, and similarly x will be depending on some other variable, the same variable, that is theta, but by some other function like g of theta. That is like you can see, for example, y is equal to sine theta, x is equal to some cos theta, right? So if we are asked to find, we can easily find dy by d theta, which is very easy. We can very easily find dx by d theta. So if we have to find dy by dx, then what we'll do is we will divide dy by d theta by this dx by d theta, and this quantity will result in differentiation of y with respect to x. So that's very simple. We have to differentiate y with respect to theta and x with respect to theta, then we have to divide the two things. Like for example, if we are given y is equal to, let's say, theta sine theta and x is equal to some theta cos theta. Now if we have to find dy by dx, then what we will do is we will find dy by d theta, we will find dx by d theta, and we'll differentiate these two. So dy by d theta will be, let's say this is first function, we have to use a multiplication rule for this. So let's say first function is theta, second function is sine theta, whose differentiation will be cos theta, plus this time sine theta as it is, differentiation of theta is 1. Similarly, if we find dx by d theta, then what we get is first function as it is, differentiation of cos theta is minus sine theta, plus this time cos theta as it is, differentiation of theta is 1. So if we have to find dy by dx, then it's very simple. This time we'll just this is theta, we'll just what we'll do is theta cos theta plus sine theta divided by cos theta minus theta sine theta. So this is the final answer. If we take one more example, like y is equal to sine u minus u cos u, and x is equal to cos u minus plus u sine u. So if we have to differentiate and find dy by dx, then what I'll do is I will find dy by du at first. Sine u becomes cos u minus u cos u will get differentiated as first function as it is, second function differentiation plus second function as it is, first function differentiation. Okay, similar is this will come out to be equal to cos u plus u sine u minus cos u. This gets cancelled out, this becomes u sine u. And similarly, if I find dx by du, so cos u gets differentiated to minus sine u plus u sine u, u is first function as it is, sine u is differentiated to cos u plus this time sine u as it is, and u gets differentiated to 1. So this is minus sine u plus u cos u plus sine u, these two gets cancelled out, so it is u cos u, and overall dy by dx will become dy by du and dx by du, dividing this. So u sine u by u cos u that is 10u. This is the final answer in this case. Let's take one more example of this parametric function, like x is equal to a cos t plus ln 10 t by 2 and y is equal to a sin t. Now we are asked to find dy by dx in this problem. So what we'll do is we'll first find dx by dt, which will be a as it is common outside. Differentiation of cos t is minus sin t plus ln of this bracket will get differentiated to 1 by bracket by chain rule, I can say. Now after differentiating this ln bracket, I'll come into the bracket and solve this tan of small bracket, which is tan theta will get differentiated to sec square theta, so sec square t by 2, and this comes out to be equal to tan t by 2 will differentiate to 1 by 2. So what is it actually equal to is I can write it as 1 by sin t by 2 cos t by 2. Sec square will be written as cos square t by 2 into 1 by 2. So this is somewhat like minus sin t plus this cos t by 2 will get cancelled by this square of that, and 2 sin t by 2 cos t by 2 becomes sin t, right? So this is 1 by sin t. So what we get here is a minus sin square t plus 1 by sin t. So this is a cos square t by sin t. This is dx by dt, and dy by dt is simply a differentiation of sin t is cos t. So let's say this is first equation or second equation. This is our first equation. So dy by dx will be given by second equation divided by first equation, that is a cos t by a cos square t sin t. So what we get here is tan t as the final answer. Okay.